It is 3 o'clock now, so thank you very much for your patience. We'd like to move on to session number 5. In session number 5, we will talk about human-non-human interaction updated. So this is about how humans and robots, AI, entities other than humans, which are growing in our world today, how they interact and the problems that may arise from their interactions. And just now, Haruka-san, the moderator of the session before us, talked about the fact how this can shape our agile governance, and I hope we can connect to that discussion. So this session will be moderated by Hiroke Kamide, and I would like to hand over to her. Hello, my name is Hiroko Kamide from Kyoto University, and I'll be the moderator of this discussion. Thank you very much. And as Inetani-san said, this will be about advanced technologies like AI and automated driving, how they're implemented in society. And this is also the expertise of our participants. So we have a robotics engineer and cognitive behavioral science, legal scholars, so people from different fields of expertise. So may I ask Asada Sensei to start? The first presentation is 10 minutes. Yes, so we did a similar thing last year, and I still had the English presentation. So I'm having my slides in English and speak in Japanese. So I might veer off track because it's confusing. The title is Rethinking Robot Ethics, Aesthetics of Existence, Social Transformation, and Agile Governance. In this project, it's related to Michel Foucault's Aesthetics of Existence and how they can be leveraged. Robot aesthetics is a research topic that has two different facets, and I'll come back to that. But let me present myself. So today we had the new students entrance seminar at International Professional University of Technology in Osaka when working. It was very busy. And I have been teaching for some time at Osaka University and doing research on robotics. So today I'd like to use the vantage point of robotics and talk about agile governance. This is the outline of my talk. I don't know whether I'm going to speak in this manner, but I'll start with this outline. It's a very rigid and hard type of matter and difficult to address the rapid changes in emerging technologies. We can't keep up with the advancement of technology. And recently, AI, robotics advanced in a very speedy manner. And with regard to that, ethical aspects, how to express them, how to think of them, and also how we can create an ethics that looks beyond that in the future. How can we anticipate where things are going and shape agile governance accordingly? Ida Sensei has talked about Aesthetics of Existence by Michel Foucault. And the question is, what ethical norms can we derive from that for robotics engineers? The engineers themselves, they perceive their work as an ongoing creative process. So normally, in engineering, normally you have a specific specification and you're trying to meet the specification with the way you design the machine or the equipment. But in this case, AI and robotics itself, as they spread through society, and when you think about the impact, it's just not just about the functional aspect that has to be satisfied, but rather what kind of impact they will have on society. So it's an ongoing process, and at all times you have to be in touch with this part while also being creative. It's not just a one-off creative process. It keeps regenerating itself. It's an ongoing process. That also includes feedback from society, and based on which you are going to change the product or change its behavior. So this is why I call it an ongoing creative progress. And then I'm saying continuously shaping their professional identity and the social environments. Because we're not just engineering things, we are putting these things out in society. They have certain stakeholders. So it's about how you become better in your field of professionality and expertise, but also what this can contribute to society. And those are things that engineers are now requested. So basically, it's not stable, it's not rigid, it is transformative. And as it says here, so it's a continuous ethical self-reflection, which means that you regularly have to ask whether how the machine is going to change human behavior, and you have to take that into account when designing the machine and when running it. And then it says technologies of the self in design and introspective design with critical feedback loops, iterative modifications, and user-centered adaptations. And I'm going to give an example later on. Robotics engineers are sometimes nerds. They have the idea that things will work the way they envisage it, but when you put it out into the world, it sometimes behaves in very different ways. So these things also come into play. How is your design, your thinking, your direction going to interact with the people that use the technology in the field? And how can you put yourself in their shoes and change things adaptively? It's a process of reflection. And to be honest, current students of engineering don't have this outlook, almost not, or not at all. So point number 3, as I said, it's basically the same thing again. Interaction between humans will be taken into account in the design on the user side, and the artificial things or robots, they themselves actually have to have ethical thinking for them to have trust, to foster trust. So we bring it from the functional perspective to an inner enriched perspective. And that's one of the aspects. And then aspect number 4, ethical fluidity and adaptability, embrace dynamic situation responsive ethics, continuously refining their approaches as societal expectations and technological landscapes evolve. So actually, as technology progresses, and society too, they will interact and have to be adapted to each other. Agile governance has been brought up several times. There is this double loop with the interaction with the field. And this is also a textbook example. I've turned it upside down as a top-down example, whereas interaction is a multi-stakeholder approach. And if you apply that to robotics, the people who design robotics will have an agile governance approach, or they don't have it now. They're not aware of it. So basically, you have to change the way of thinking and make sure that people who design robots, they will be able to have this kind of outlook. So before you do this discussion, it has to start at the education level at university. It's not just about robotics, also about the way universities are organized, because general knowledge, liberal arts are left behind. Only expert knowledge is taught, and this is a basic underlying problem. This slide mentions some different approaches, but basically the question is whether engineering itself has this awareness. Right now, the situation is that we tell researchers once they're ready, you have to adopt a different approach. You have to step on the user side, run agile governance approaches. We're trying to instill this problematic awareness in them right now. And I'm going to skip this because it's rather self-evident about transparency and accountability, ethical risk assessment, flexible policy adaptation. So this is an ideal theory, basically. And regarding the dynamic reflexive framework, it basically means that the framework itself has to become adaptive and that it's going to be adapted as we go on. And I'd like to give some specific examples at this point.
This is Robot Save Japan. James Wright, he's an anthropologist, had an interview to have a research at a care house. And he researched how robots are used in care houses. He actually went out to the field and interviewed some people on how the robot is used. Paro is the most soothing robot. And it's been shown that it's very beneficial to treat dementia. But depending on a person, those elderly people become too obsessed with the robot and becomes isolated socially. As robot designers, there are various parameters, and basically they try to install behaviors of the robots to have benefits for the elderly people. But actually in the field, it's not completely understood or predicted how that robot has an impact on the elderly people. So it's not that engineers can design robots 100% properly for the benefit of the elderly. Therefore, the feedback from the field is necessary to redesign the robots. I think that's the idea of agile governance. This is a typical example. In different examples, there are some examples where robots were improved. But as I mentioned, engineers or designers of robots themselves need to be aware of this issue. However, there is no such framework yet. So the implementation of agile governance is the question because the engineers are not catching up yet. I think there are two roles of robot engineers. Number one, of course, they need to design robots. But the second thing is, as a designer, as compared to users, they need to act as a facilitator to put the opinions or feedback of many different people. They need to be a bridge to connect people from many different backgrounds. I still have 3 more minutes. And the other aspect, I said there are two aspects, and the second aspect is about the ethics of robots themselves. I haven't talked about it yet, but robots themselves can be moral agent. And this slide has nothing to do with what I'm talking about. I've been doing the research of the pain by making robots feeling the pain can empathy with the people, and that way robots themselves can have ethics. Some people would say that that's not necessary for robots to have ethics. However, as an agent to coexist with human beings, robots themselves, it might be a good idea to let robots have their own ethics? It's a very difficult question, but this is related to the question of how human being has come to have ethics. And that way, a better interaction will be possible between robots and human being. And the conclusion is that engineers haven't caught up yet. And in order to solve this problem, we have to rethink or revisit the curriculum of universities because they're rid of liberal arts. Our university teaches specific things, but we think that's not appropriate to teach only specialty things. Liberal arts is very important. That's our opinion. However, current university students may not like that idea, but including that, we need to think about how to solve the issue agile governance involves. You have 30 seconds left. Do you have any questions or clarification to Dr. Asai? Basically, I'm very interested in that topic. Robot engineers themselves, how can we let them have their ethics? We shouldn't introduce punishment to those. We want them to voluntarily have interest in ethics. I hope that discussion on that matter will spread. Next, Shibata-san, Dr. Shibata, are you ready? Yes. What I'm going to talk about is this. My name is Shibata from Kyoto University. I belong to Kyoto University, but I also work at a company. My job is to deal with private companies and tourism agency to provide consultations about risk management, especially focusing on safety management. Recently, I provide consultations about robots. So from that perspective, I would like to talk about robotics and agile governance. Today's topic is human-to-human interaction. So I would like to talk about the interaction between human and robots. These are recently developed robots, especially the upper left one. You may have seen those robots at family restaurants. Those are the robots which have already been implemented in our society or which have been already demonstrated in a society. And the lower right is Nikobo. These are the robots we are familiar with in Japan. And the next slide, these are the robots which have been developed in the US and China. AI's development's been making big contribution to the development of those robots. They perform very well, surprisingly well. In overseas, robots are designed in like Star Wars character-like ways, and in Japan, they are cuter like Doraemon. Talking about the functions of the robots, there are key technologies around the functions of the robots. The left side is input process and output. Input are about sensors. At the upper right, there are many sensing technologies listed, and the process is by actuators. There are many new actuators being developed. Many new robots that I introduced have AI functions. So the development of AI is making big contribution to the development of recent robots. The generative AI and large language models being developed, and they've been used for the development of recent robots. Next, today's theme is human-non-human interaction, and here I would like to talk about non-human interactions. At the left, they are industrial robots or industrial machines, operators physically send command so that those machines can do physical works. So those are the world of industrial robots. And with the AI at the center, if you have any questions or if you'd like to have advices, then you can ask questions to AI and you can get response to use for your work. Or you can sometimes get emotional stability by getting answers from AI. And at the right side is AI plus robotics. In this way, if you have any wishes, AI will give you instructions or it can interact with you and have discussions. Recently, AI agents may ask other AI or robots to do something, so it's a completely different world. In this situation, even in industrial robots, we were worried about any injuries. But in robots with AI, you may worry about doing jobs close to AI. And this is Isaac Asimov's 3 laws of robotics. And we were expecting robots to have all these architecture. But if you look at the news reports in the past 10 years, you see those news reports like AI chatbot Tay turned into racist, or maybe they use secret language.
There was one recent example in the Nikkei newspaper that robots playing chess, they were trying to cheat or bend the rules from a human perspective. So these are examples that we see, and we might wonder, is this okay? We might become anxious about that. So the question is, when humans interact with robots, from an error perspective, what can produce errors? I've mentioned the Turing test here, but let's skip that. The left-hand side shows what humans do and the kinds of errors that they make. And I'm just mentioning the violation or intention because people or human beings have the ability to intentionally deviate from the rules, which often becomes an issue at construction sites or in factories. But AI actually also has the ability to do things that look like violations from a human perspective or in our eyes. And some of this is due to the learning process. So similar phenomena occur. And the yellow part indicates the different actions and errors that coincide with them. One is omission errors. They don't do what they were supposed to do. Commission errors is they were trying to do something, but they did it a different way. And this often comes from bad decisions, and it's something that also occurs when it comes to AIs. So on their own, what they perceive as an error and what we perceive as an error might be different. And when AI and robotics are implemented across society, and this is the slide that I want to highlight most, what happens in society is that there is a system of systems, and robots, when they are being implemented in society, they should be implemented in a way that oversees the whole risk to the whole society. And if we go back to the input, process, output paradigm with all these subjects that are intertwined in a network, we get to an overarching network that is the nation, and then we get to companies, management systems, and individual people. So as it says on the right, it's a nested structure. It's a multi-layer structure that we can see in reality. And the other aspect is that it's multi-layer. So it might be a physical interaction, it might be a communication level interaction, or if we are looking at a business, it might be a monetary interaction where people pay for certain services or products. So these interactions spread over many, many layers, and that's what the actual society looks like in reality. And if you implement robotics in this, what does happen? All these nodes used to be just human beings, but increasingly they will turn into AI, will turn into robots, and we have to think ahead what might happen in these instances. So if we look at the risk for society as a whole, in the past, we would focus on the components and then look at failure modes, but we're not able to assess the whole risk anymore with that approach. So we have to focus on the interactions and the kinds of errors and failure modes that they can produce. For example, we were talking about communication between AI systems, and in those cases, as Martin Lexon says, the STAMP and STPA, those analytical approaches will come in handy, and there are 4 guide words that I'm showing here on the slide. They will be indicative of how we perceive, how we go about analyzing interactions and failures between these entities. And this can be analyzed at the human level or the AI level. Once robotics comes in, though, it transcends to a physical body layer, because those physical systems also take actions. And this will call for an analytical approach that we call HAZOP, which also would look at the interactions and use that as a springboard to analyze risks. This risk assessment approach or methodology, what I'm trying to think about here is that when we implement AI and robotics in society, how would the risk look like? There may be new standards like machine safety and function safety that we used to have, but things related to AI will more and more emerge. And we can use those to perform risk assessment. And in these cases, those 4 quadrants will play a role, which is about what do I know and what do I know about what I know. Regarding these yellow quadrants, they can be risk managed, but there are still the unknown unknowns. And those, whether you intend it or not, this residual risk will remain, and you have to be aware of it, or you have to be to accept it or deal with it. So based on all of this, we will still probably have to confront ourselves with AI and robotics and come to terms with it. And here I've analyzed the benefits and risks for individuals and society and divided it into the different communication styles that might occur. And every layer has its own pros and cons, benefits and risks. So we have to weigh them carefully to come to decisions. So before we talked about the principles of robots, and if we think back to the discussion about zero risk that we had before, what level of safety or security is safe enough? That would be the question, and it would have to be a balanced approach, weighing different factors. And if we bridge the gap to governance, the double loop learning process will play a role, which is one of the focuses of agile governance. And what it says on the top right corner, emerging technologies. We can't deal with the unknown unknowns, so we have to gather data quickly, collect data, and increase our intelligence to be able to take measures and reiterate that cycle over and over again. This cycle, at some point, if there's an accident, for example, it should be shared across people, across society. And the bottom left part talks about the fact that if AI robotics do what humans used to do, for example, industry, we might require 100% reliability. But even though AI and robotics might be better at some things, they might be worse at other things. So there will be AI-specific errors, just as there were human errors in the past, that we have to anticipate them, expect them, and come to terms with them. On the right-hand side, it talks about governance by AI, because AI's behavior has to face some oversight from human beings. But the question is, to what extent can we do that? If we try to do it in a perfect way, we will still need AI to support us in overseeing AI. So the question will be what role distribution between people and AI in that context. And in yesterday's session, I also followed yesterday's session, and we brought up the question about agile governance, what it would look like in the context of AI and robotics. And this is a picture of what it could look like. On the bottom, the blue line is the existing governance, what it used to look like, creating laws, taking 2 or 3 years to create a law, and then execute it. And on the bottom, it talks about the different steps, developing AI and robotics, using it, and producing results. And the speed is extremely high nowadays. So the existing approaches to governance, this blue layer, can't keep up. So we need higher cycles of governance, which is agile governance in the middle layer, and which will be increasingly in demand and will be necessary. So AI robotics, when it's going to be implemented in society, one thing I'm wondering about is what it says at the top. So first of all, what about the unknown unknowns? Who is going to take responsibility for this part? And I think this really calls for input from the legal community. And the other one is the business layer. So as the steps, yes, okay, I have to stop. I see. So what I'm trying to say is that we will need to leverage AI to build agile governance systems in the future.
Thank you very much. You talked about systems of systems. That's related to Dr. Inatani's presentation as well. It expands as a network. It's an ACTA network theory that's very interesting. How to solve this problem, technical problems, should be discussed amongst the legal people. Now we have Dr. Philip Morgan. If you are ready, please start your presentation.
Yes. Okay, that's better. Oh, wow. So I'm going to follow the last talk. There are so many synergies, and I'm going to talk about sharing the world with automated and AI things, particularly thinking about designing with humans in mind, designing AI with humans in mind for ethics, responsibility, assurance, and various other things. I'm not going to go through this entire slide about me. Lots of this is in the program, but I'm a senior professor of socio-technical aspects of artificial intelligence, robotics, cybersecurity and automation at Cardiff University, at Wales in the UK. And I hold a number of other positions in other universities as well as a visiting professor. So in terms of the content of my talk, I'm going to start by being quite controversial and asking whether we should be bracing for a robots and AI apocalypse. Are we heading in that direction? Hopefully not. I'm going to talk about trust in AI, robotics and automation. I'm going to talk about who to blame or what to blame when things go wrong, because inevitably they will. I'm going to give you some examples of AI smart agents and what's going on in that space. And then some examples of cybersecurity and privacy considerations, and with some key takeaways at the end. So winding back about 18 months ago, I was in San Francisco on a conference called Applied Human Factors in Ergonomics, and these are actual photographs that my PhD students took of me stepping out in front of autonomous vehicles. Probably not the safest thing in the world to do. It wasn't a controlled experiment, but I wanted to see if these autonomous vehicles would stop and how they would behave. So my PhD students were quite cross that every time we left the restaurant, I would stand out in front of one on a zebra crossing and see what would happen. And they stopped, which was brilliant. That was fantastic. But what I tended to find is after a short period of time of standing in front of one of these autonomous vehicles, if a human driver in a vehicle behind started honking their horn, the autonomous vehicle would start getting really, really impatient with me and start edging towards me as if to say, get out of my way. And that was quite disconcerting because I've been working on human aspects of autonomous vehicles for about 10 to 15 years, and I didn't realize that they were programmed to do this, to sort of say, you know, you need to move out of the way. A couple of months later, there were 2 accidents, a lot of people probably know about these, involving autonomous vehicles in San Francisco. And as a result, 50% of the GM's Cruise fleet was slashed and the CEO was fired. One of those accidents involved a pedestrian who had been run over by a non-autonomous vehicle, and then the autonomous vehicle didn't correctly identify that as a person, clipped onto the person and dragged them 12 meters down the road. So this is rather interesting because are we actually ready for this kind of technology? There are lots of other examples, autonomous vehicles not being able to identify wet concrete, the police pulling over autonomous vehicles when there's no driver in there to find out what's going on, and then some really, really serious incidents, for example, involving Tesla vehicles a number of years ago in autopilot mode. So we shouldn't be surprised by any of this because Lizane Bainbridge in 1983 actually warned of the ironies of automation and said, like with many other things, for every action there's a consequence, and we have to think of the consequences when we're designing. Raja Parasuraman and Riley talked about the misuse, disuse, abuse and overuse of automation, and more recently some people have been talking about the same things in the realms of AI. So we have to think about the consequences of things potentially going wrong when we're designing and when we're legislating. There are so many examples, we've had some of these already, of things going wrong recently over the last sort of 5 or 6 years. I gave some examples, but there are lots of others. So are we actually risking an AI and robot apocalypse? Are we advancing technology too quickly without considering humans, human interaction with this technology in a steady way? So, like, we've got the utopian scenario where robots can help us perform multiple tasks like medical robotics, etc. Then we've got the doomsday scenarios where robots take over the world. But really, to the right of this slide, this is where robots are today. So we've got robots that can help us go about our everyday lives. We've got manufacturing robots. We've got autonomous vehicles that are being deployed, whether we like it or not. And we've also got these kind of things where robots are being armed with weapons to go into war situations. And what we need to try and avoid is this kind of situation, which is from one of the classic Terminator films, where things go automated and rogue. So are we humans ready for more advanced automation, robots and AI? And what don't we understand about humans and technology so far? And there are a lot of questions, including trust, blame, acceptance, adoption, continued use, and these all have links to governance and legislation, not to mention cybersecurity and privacy. So where do we start? Well, one of the tricky aspects we have is how do we define trust in AI and automation? It's very difficult. We've been trying to do it for the last 30, 40 years, and there's no universal definition. We know that we need to design and account for appropriate trust and not over-trust. We shouldn't be over-trusting things because then we just become completely reliant on them. And it takes predictability and time to get used to these things, but some technologies are being developed and deployed at such a fast pace, we don't even have the time to get used to it. And for example, we have to think about how we actually measure trust as well. And there's a lot of research out there involving questionnaire measures, etc., which are quite subjective on a scale of 1 to 10. How much do you trust this piece of automation or AI? We have to think about objective measures as well. So measuring brain activity, eye movement, skin conductance, etc. We can't just be relying on subjective measures. There are a number of projects that I've worked on over the last sort of 10, 15 years or so involving the design, development and potential deployment of autonomous vehicles. So this is just one of them called Ventura Autonomous Vehicles for UK Roads, where we were looking at trust, acceptance, adoption, cybersecurity, etc. And just as a takeaway message from this slide, this was a 3-year funded project costing £5 million in funding. And we looked at level 3 partially autonomous vehicles where humans had to retake control of the autonomous vehicle at times where it couldn't drive itself. And my message from this project was, it's not safe. It's not safe, we can't do it. It can take up to 1 minute to drive normally again when retaking controls from a partially autonomous vehicle. That's not going to work in cities like London and Bristol in the UK, where we were testing these things, and in most other parts of the world. And there are numerous other examples where we tested human interaction with these autonomous systems, with pedestrians stepping out in front of them, with cyclists pulling out in front of them, and so on. And again, we found that subjective trust was very, very high, but actually physiological trust was quite low. So we need to think about this as well. There's another autonomous vehicle project that I worked on. I was leading on human factors on this one, where we were designing autonomous vehicles for people who might need them the most. So for example, older adults, individuals with visual impairments, auditory impairments, disabilities, and so on. And this really struck me as a really important project because it had a user design theme throughout. Rather than just relying on the literature on what we think people want, we actually spoke to hundreds of potential users and tried to understand what they want. And we built these into the systems and took lots of measures of their behavior and performance. And it was a huge success. Some of these vehicles have been deployed in retirement villages. We've designed human-machine interfaces for these vehicles, and so on. And what the potential users want is quite different to what some of the literature says. And there are some examples there: simplicity, adaptability, and lots of people mention certification, legislation. They want to know what the legislation is. And a more recent project with collaborators, including Professor Inatani and Professor Asada, we were looking at what happens when autonomous systems go wrong. So in this case, again, autonomous vehicles, what happens when an autonomous vehicle performs an action, like a discretionary action, like overtakes a bus, for example, that's stationary, when it's safe to do so, but then an accident occurs, a pedestrian steps out in front of that bus and the autonomous vehicle couldn't detect it. One of the key messages from this is trust plummets. We don't like that when an autonomous vehicle, when a robot performs an action and something goes wrong afterwards, because it's supposed to be perfect. Yet when a human performs that action, even though the consequence is negative, we trust the human more, even though 95% of all road traffic accidents are caused by humans. So it's very, very interesting. We conducted a lot of experiments. I think it was 24 experiments as part of this project, including using AI smart agents and various other things to see if we can try and restore this trust in the event of things going wrong. It worked under some circumstances, particularly when we started thinking about weaker robots and explainability. So explainable artificial intelligence, so trying to understand what the system is doing, why it's doing it, and then some sort of reassurance after potentially something goes wrong. And this is just an example of some of the agents that we were using within these experiments. One of the last examples I'm going to give is, should autonomous vehicles be allowed to break the law? That's an interesting question. So for example, imagine this scenario where an autonomous vehicle is driving down a road and a pedestrian suddenly steps out in front of it. Now, what would we do as humans? We would, if the lane ahead was clear and there were no pedestrians, we'd probably swerve to avoid the pedestrian. But autonomous vehicles are not permitted to do that. So ultimately, they would collide with the pedestrian. So we measured under various situations what would happen if autonomous vehicles performed these discretionary actions. If they fell within the law, so if they crossed a double dashed line in the middle of the road, that was deemed as appropriate. But if it crossed a solid white line, that was deemed as inappropriate. We would actually prefer it if the autonomous vehicle ran over the individual rather than broke the law. So that's quite interesting. I'm just going to wrap up with some examples of a recent project involving AI smart agents. So this is a collaboration between 7 universities in the UK, including my university, Cardiff University, University College London, Bristol, Bath, etc., where we're looking at the design of AI smart agents for a variety of application domains, including smart city design, including pandemic resilience, financial stability, healthcare ecosystems, and environmental intelligence. If anybody would like to take a picture of that slide, I'm sure it'll be available later. These are our core team. So we've got over 50 people working on the same project, including 15 PhD students. Infrastructure and governance is key to this project, as is human-centered design. So for example, we have a vision of what things kind of look like there in terms of how AI agents work and how we can affect the behaviors of collectives through refining AI, artificial intelligence agents, drawing upon multiple data sources to help us make more informed decisions. But going back to one of my earlier points, we can't get to a level where we're over-trusting these systems. These are just systems that help us to make decisions. So this is an example of an environmental intelligence situation where we're drawing upon so much data. So for example, the Met Office in the UK have given us £1.5 million worth of data to go to town on and try and understand how that can support our decision making. And going back to one of my earlier themes, there is a human-centered design and governance and regulation theme throughout. We need to understand how these are designed for humans, with humans in mind, how they're legislated, and then how they're rolled out. I'm going to skip past the cybersecurity element because I'm going to run out of time, but it's just to say that we've recently published a paper that measures human cybersecurity vulnerabilities, and it's the most powerful tool on the market. We can account for up to 60% of the reasons why we as humans engage in cyber risky behaviors, including our psychological ownership of the devices that we interact with, including our organizational commitment and not just individual differences factors like impulsivity and risk-taking. So some conclusions, some takeaways. I don't think we're heading for an AI and robot apocalypse anytime soon, though we must have stronger international governance, legislation and policy for AI, robots and autonomous systems. End-user uninformed AI and robot design must not happen. Multidisciplinary, socio-technical, human-centered approaches, groups and centers are crucial. Trust, ethics, responsible design and assurance is vital, and it's crucial to get this right for legislation. Autonomous vehicles present a useful safety case. We don't always have to focus on these, but they highlight the importance of some of the interactions that we have in the world. And research on smart AI agents and chatbots is questionable, but they are being introduced into many high-stakes environments, and we have to be really careful, including pandemic resilience, government decision-making, and so on. Cybersecurity, we know our vulnerabilities, I know our vulnerabilities, and we can fight back, and we must ensure a secure by design approach. Thanks for listening. It's much appreciated.
Thank you so much for the great time management and for completing your talk in time. I'm also a psychological researcher, so I'm very interested in subjective trust and physiological trust, why they are different, and I'm very interested in this individual research. So to pick up that, but also in relation to what others talked about, I think trust is really a key term, and I would say when you look at things in the lab and measuring trust, I think that's really a positive approach. What is the approach to system design and how can this feed into ethics? I think that's something that we have to look at across field. So lastly, we will have time for an overall discussion, so maybe we can pick up on some of the themes that were alluded to during your presentations. But before that, the last speaker will be Tatsuhiko Inatani. And may I call upon you to speak? You have the floor, Inatani-sensei. Yes, thank you very much. So from my part, I am a PI in a project where Kamine-sensei is also participating, so I'd like to give you a report on some of what we do here. So this story also ties back into how to implement general governance, what was picked up in the last session, and how we can use this information to design legal systems. I think this is the overarching topic. And people who have listened online and in this venue might have realized that, how should I say it, the research topics are really multidisciplinary. And it spans not just law, it goes in very different directions as what we would normally expect from law. And it's also very interesting how this can be reflected back into legal scholarship. And maybe there are interesting discussions to be had. So without further ado, what is the motivation for this type of research that we do? In Japan, people and their emotional bonds that they develop with robots are liable to change people's cognition and change people's behavior. And this is what many institutions are trying to do in Japan. And here it shows the Panasonic robot Nikobo that's also used in joint research by us. On the other hand, Glubex has produced a robot called Labos, I think. So these are robots that really invite to talk to them and play with them in this very, very playful design. So from our perspective, we want to look at what benefits these robots can bring. And one thing is that by living with these robots or cohabiting with these robots, they use data and optimize their behavior. And this can help elderly people living alone who suffer from degenerative cognition. That's a societal issue in Japan. And it can maybe help with people who can't go into therapy or maybe children who have issues preventing them from attending school. So it can help people change their cognition outlook, and change their behavior, and maybe contribute to people's overall well-being. So if people select this kind of robot from the market, and there is a selection process where the best robots survive, robots that are beneficial to people will remain at the end, and we will get into a situation where robots are becoming our cohabiting species. That's the hypothesis that we have based our research on. Now, of course, this is not all there is to it. There are all those different aspects like legal issues that were raised. And one of the issues that international guests will also agree with, and there's also a reaction that I often get, is if we have these emotional bonds with machines and interact with them, if people's cognition changes, behavior changes, all these changes, this kind of design, this function, doesn't it violate people's dignity, people's agency or autonomy? Doesn't it enter in violation of people, of the idea of a self-determined individual? If people live with these entities in their daily life, there is a risk of misuse and overuse of data, and also of unintended consequences, such as privacy violations, some people would say. And there have been platform regulations that also tie into this. So if these services and products become more widespread, aren't we at risk of adopting unneeded or harmful technology? Or what impact does this kind of technology have on people, on their cognition and behavior? Couldn't there be the risk of creating unintended consequences? So how can we solve these issues, or how can we think about these issues?
What we have to think about first, if you look at this problem from the standpoint of Western modern idea, I think it's difficult to deal with this issue by using the law based on the Western modern ideas, and that might not be appropriate either. I'm saying this because that kind of human perspective philosophy in the philosophy of the question has been raised so many times, like Foucault's. There was a discussion about the knowledge, power, and subject. And as Dr. Kamide mentioned, the actor network theory, the subject is not universal or fixed. The subject, we think, is a matter of course, is something which happened to be created. Dr. Asada talked about the ethics that robot engineers should have. robots and AI's behavior, whether it's intended or unintended, that inevitably having impact on human being, and we have to understand that impact in designing robots. And the next thing I would like to talk about, the perspective. I think there is a perspective Japan traditionally have. For example, in Buddhism, we have the idea of emptiness or dependent origination and selflessness, including human and non-human beings. We have a dynamic network, and as a connecting point, we have our society. That is the traditional thinking or thought in Japan. The human being in Japanese means in between. And that kind of ideas and that kind of thinking is something we have in Japanese society. And the difference of perspectives. Dr. Kamide is an expert in that. The Japanese perspectives or European or American perspectives are different. Psychologically, there is a difference, and we have evidence of that difference. And as Dr. Shibata mentioned, something like system of system that might bring about risks, and we have to think about how to deal with that potential risks. The way of putting individual at the center, that way of thinking, when there is a problem in one component of the society, we tend to think that we can solve the problem if we can fix that component. But in a society where robots and human beings are interacting in a complex way, it's not that one component is causing a problem. The problem lies in the interaction or the relationship between human being and robots. So that interaction and connection need to be fixed when we have a problem. And further on, this kind of thinking in EU AI Act human oversight. And this is about human being needs to control the risks of the robots. And that is the dominant idea in Western countries. But if we have a mechanism in which risk is controlled, I think that should be fine. Of course, there was a talk about unknown, and Phil talked about unintended consequences. But unintended risk can happen or should happen. So based on that potential risk, we have to continue to control the risk, and we have to have that methodology. And that's what we talked about in the first session, or also where we should apply agile governance. So our aim is to solve this problem using agile governance. But in order to solve this problem, we have to have a lot of understanding and knowledge. The most difficult thing is that when we interact with robots, what's happening? And that's still unknown. We have to understand what's happening in the interaction between human being and robots. Otherwise, we won't be able to come up with the mechanism to control the risks. By having interdisciplinary risk, by using the neuroscience, when we are having interaction with robots, how human beings are understanding the robots, that can be understood by measuring our brain waves. Or when we are obsessed with robots, what's happening in the brain? We can measure that as well. Or how are we perceiving the robots? That can be understood through anthropological research. And another very important thing is there is a huge difference in terms of the culture. Phil had a joint research, but our part and Phil's part, in order to compare the culture, we conducted the similar experiment. An interesting difference between the two was who to blame. There was a difference in terms of who to blame. For example, Japanese person and British person, when we compared those two people, if a person jumped out behind a car, and if a car hit the person, who should be blamed? And British people tend to think that person has an exclusive responsibility. But in Japanese society, we tend to think that that person who jumped out also had a responsibility. So we tend to blame many different people, or we distribute the responsibility to multiple number of people. Or if we expand this thinking, the engineering process or iterative, what is happening actually in the ground, we have to understand that in designing robots further, what we have to have in mind in designing process, and that needs to be clarified through experiments. And at the same time, we also have to think about the legal aspect, how we can improve the laws and how we should update the laws to deal with those problems. Because those problems, the companies who deploy robots and services, how seriously they understand the risk robots have. So how seriously they can try to manage the risks is the question. If companies control the risk, so we have to create a system where the more companies control the risk, the more benefit they can get. Or maybe we can utilize insurance. We can create incentive by giving insurance premium. That kind of mechanism is needed. But in order to do that, we need to understand what's going on. And what's we know now, there are some things that we already know. One thing is that the emotional bond between human being and robots, unintentionally or unknowingly, human being process information, and we unknowingly create a model on what kind of existence we are in a society. And we have cultural difference in that. But what is interesting is that those symbiotic robots, those robots, when they intervene, why is it that human beings interact with those robots? And what was interesting is that those people think those robots do not have any emotion, but unintentionally or unknowingly, they unintentionally create a bond or become obsessed with those robots by experiencing unexpected behavior of the robots. And those unexpected behavior with the robots may be changing the wiring of the brain of the human being, and that may be also related to the risks. And that kind of analysis or that kind of research, I think, is a very interesting point in controlling the risks robots may have. And the other thing is that we have different stories. Both in the case of robots and Nikomo, as you can see, they are round, they are Doraemon, they are cute. So I think how much do we like to have interaction with those non-human things? European or American thinking is that the thinking is arise from our internal self, but Japanese people, a human being, and also the emotions can arise from the interaction with other things.
So don't necessarily perceive this as something that's inconvenient, and maybe we could confirm the hypothesis with brain scans at some point. So based on all of this, how can we find an international approach to all of this, or an international system that works across the world? Because this can be a threat or beneficial to all of humanity. So we have to pay attention to these cultural differences, because our world outlook and the view of the world that's prevalent in other countries, there's no right or wrong. And if there was right or wrong, we could just select the one that's right and adapt the risk. And this would lead to a decisive approach. But that's not the case. So what we rather need is focus on what the problem might be and build up small steps of agreement, even if they're imperfect. And we need to create the evidence for that with our research. And if we can then quantify the risk, this will also play together with this approach. So I spent a lot of time on this, but yes, thank you very much for listening. Thank you very much. I mean, this is really strikes at the core of what the session is about. And you were saying it has to be an agreement that's narrow and shallow. So it's an iterative approach with small steps, but it will reach a stable level somewhere in society. And the question is, how can that happen? One aspect is that the engineers themselves reflectively approach it with their own ethics. Shibata Sensei mentioned the system design, also the culture narrative, culture philosophy approach. How can all those be combined, and how often does the system have to be updated? Maybe there are opinions or comments on what all these aspects. And the problem of trust that Mr. Morgan brought up is that in order for negative things not to happen, we have to go from 0 to minus. And if we do so, the system design or ethical approaches, risk assessment, all of that has to be rebuilt into society. We have a certain default towards robots. Maybe you have trust, but other cultures might not have that trust. So is that possible? Do you need specific cultural or education premises for that? Is this trust generated organizational? And if it's generated by an organization or by some technology, will it be ethical, this kind of trust? This collective responsibility was also brought up. When we have all these different stakeholders, who has what granularity of responsibility, and what kind of responsibility do we expect from users and engineers? All of this can be differentiated. And I'm going back again and again to Mr. Morgan. What can we do? What can't we do? If we don't know this about the technology, we'll end up trusting them too much, and unintended or unexpected consequences will ensue. So how we share information across society is also an important aspect for agile governments. And personally, that's something that I want to ask. Agile governance, the system involves many, many different stakeholders with different expectations. And is it something that we can also use for interdisciplinary research? So can we also use this agile governance approach for interdisciplinary research? So these are the questions and the thoughts that I had, but maybe we have similar things from other participants. May I? Sorry. May I show just one slide? The specific approach that we take, if we look at it from a robot perspective, I actually participate in RoboCup. There are different leagues, not just soccer or football. For example, a competition for supporting robots, helper robots, things like shops and cafes. And I think this can be a platform for social experiments. So there was this issue of how can we reach agreement, how can we reach consensus. RoboCup is being done in 50 different regions and nationalities, so it's a cross-cultural venue. So the question how we set up these tasks is also a cultural thing. So one approach would be that the multi-stakeholders on the ground look at, what's happening, what are we going to do. Maybe they can think about this together. Of course, it's not something we actually do at RoboCup, but I think we have to get there at some point. So it has to be on the ground in the fields, and everybody has to monitor things together, look at what's happening, and look at what the approaches can be cross-culturally. What you just said is actually what I was trying to say when I talked about narrowly and shallowly, and it also talks about all these phases, because what you mentioned is, and also in the session before, we have this thing that we call the inner loop, which is in the field, on the ground. What's happening there? What's the threat that people perceive? What are the problems? What are the topics? We need more places of dialogue where we can have these interactions. Agile governance has multiple layers, as was mentioned, and within these layers, we have the players that influence each other. So if we take the example of RoboCup, when we implement these robots, some people might say this is a way that applies to a specific kind of robot, but one country maybe doesn't like it, and maybe the country that doesn't like it but maybe there is one stakeholder that can bring it there and that has a different approach. And then maybe these stakeholders can discuss again, and they can adopt new rules, and those are then reflected to another layer. So it's not that there's a center. We are building up these small steps and multiple cores. If a specific person or group has their ideas about the issues or their approach, they can then share it across the network. I do think that you can use agile governance for this interdisciplinary approach. So maybe we can think about this in this team. The thing that was most interesting for me, and I skipped it in my own slides, is the fact how can robots develop their own ethics. I think this is one of the main challenges. And at this point, my conclusion is it might be difficult for robots to have this own ethics. Yes, I could speak on this for ages, but one hypothesis is that if we equip the robots with their nervous system, with the ability to feel pain, they can identify with others, empathize, and create morals. And this will connect to having an ethical view. But of course, there are many issues with this. It's not so we should approach it not with a wide scope, but with different steps and small parts. But basically, you have this robot that will be able to feel pain and does social interaction, including culture, committing to society, or society commits to that. And this is when, for the first time, there is a possibility that these artificial objects have ethics. So it's not just how it's designed, but also the interaction that it has with society. And this will then affect the background or the bias that it has. And this itself will also create new moral tendencies within humanity. I'm wondering, when we talked about the chatbots, in order to fulfill your objective, maybe they will try to, subdue their own pain and make themselves not feel pain anymore. Much of our own ethics comes from the fact that we are entities that will eventually die, right? Yes, we've been talking about these ideas of pain and death in my research, and I'm going to announce it when we get to any results. Recently, because of LLMs, artificial consciousness has become an important topic. And we have skin in the game when it comes to asking the question whether AI can have ethics or can have morals. But it's difficult because they don't run their own risks from a neurocognitive perspective.
Yeah, I'll just be very brief, and I'll add a couple of things. I think one key thing that we need to focus on is robot and AI capabilities. And a lot of us in society, a lot of citizens out there, we don't all understand what robots can do and what AI can do, or what robots are, or what AI is. And then we have these perceived capabilities of what these machine systems can do. And if things go wrong, we place a lot of blame. And there can be cultural differences, as Professor Inatani referred to, and we need to do a much better job. And I think like RoboCup and examples like that are very, very good examples of exposing people to what these capabilities are, so that we can better understand what these systems can do for us, but also understand their fallibilities like we understand our own fallibilities as humans. So this experiential approach is crucial, and that links back to some of the things I talked about in relation to trust. In order to build up trust, like we build trust in each other, we need to experience each other, and we need to understand each other and understand what the good things are and what the not so good things are. And we need to do that with robots and AI. Else we're at risk of deploying things at scale to try and achieve behavior change at scale with systems that a lot of people don't really understand. So we've got a lot of work to do there, and agile governance will provide a very, very strong framework to do that. But we need to do it internationally. We can't do this in silos in individual countries. Otherwise, it's not going to work globally. And this technology is advancing at pace, and we have to keep up.
最後に、今までの話をまとめる話になるかわからないんですけど、やっぱ最終的に
So ultimately, how human beings interpret or understand a thing is the key. And the capability Phil just mentioned is also about how human beings interpret the things. The question is how we can create a model, including robots. That will be a very important key. Thank you. I'm sorry, we are running out of time. Thank you very much. Please give a big hands to the presenters. Thank you. This concludes session 5. Thank you.